But again, I'm Thomas Gardner, and I'm going to give a little talk about PowerShell. It's going to be pretty high level. We're not going to get in any code, or we're not going to get in any programming. It's just an introduction to some terms and maybe some things that, if you want to start writing PowerShell scripts, you should probably know ahead of time. Just from a little experience that I've had with Googling some issues. Anyway, so PowerShell basics. Batch files or so 1990s. Let's get started. So we're gonna cover a couple things. One is just a little background about PowerShell itself. I'm gonna talk about scripting and then what Windows execution policy is and how to bypass that to actually execute your own scripts and test stuff. And then lastly, we're gonna go talk a little bit about WMI, which is interfacing with the Windows operating system itself. And using some tools. It's going to be an introduction to using some tools that malware can use to do anti-forensics type stuff. So, a little bit of background. PowerShell was originally created for sysadmins. It's mostly used for automating processes, which to do that you have to write scripts. But it's also done interactively by the user. So I think now, since maybe Windows Vista, every Windows machine has had PowerShell on by default. If I'm a malware writer, I like that because I know what's going to be on a machine ahead of time. For example, I might not know that Python's going to be on a machine ahead of time on a Windows machine. So maybe I don't want to use that. Maybe I don't want to write Python scripts, but I do want to write PowerShell. It's also built on top of Microsoft's .NET framework. If you've never heard of .NET before, it's a sprawling mass of crap, for lack of a better word. It's actually really nice because you can do a lot with it. The problem is it's not very simple, or I guess very easy to use unless you've had a lot of programming experience ahead of time. Also, lastly, I'll put a little disclaimer on this. Officially released in 2006 according to Wikipedia. We all know how reliable that can be. I didn't check my citations there. So if I were still in middle school, I would get an F on this report, but...
Wait, you're not still in middle school?
Yeah, I know, right? Believe it or not, I'm not still in middle school. So,
were you born when
officially released in 2006, according to Wikipedia. All right, let's actually get into scripting in PowerShell. So like I said before, the original purpose is automation. It's made for system administrators. And it was made as kind of a, sort of supposed to be an improvement on batch files. And in order to do that, Microsoft decided, hey, let's make this object-oriented to help with creating new objects, creating an easier way for people to, I guess, program their and interact with Windows machine. So object-oriented just means you kind of describe programming language, or you describe objects in Windows as you kind of would in the real world. Like a car has two wheels, so is a truck. They're both vehicles. So vehicles would have, sorry, did I say two wheels? I meant four before. Anyway, I'm getting off track.
My car has two wheels.
Congratulations, Corey, your car has two wheels. All right. Anyway, back on track. Another term that you might want to know ahead of time if you're starting to get into PowerShell is a commandlet. It's used everywhere. Basically, a commandlet is just a little snippet of code that's pre-packaged and pre-made for you as a programmer to use ahead of time. You don't have to recreate things. You don't have to recreate the wheel, as my old math teacher would say. It's just, technically, it's a compiled .NET code. And it works just like every tool. If you use a lot of Linux, grep could be its own commandlet, ls could be its own commandlet, stuff like that. And lastly, modules. Modules are a lot like commandlets. I think they're technically just different on the back end, but they work really similarly, and they have some of the same, they have very similar output files, like a .ps1 is just a script, a .psm1 is technically a module. And there are some extra features you can do with modules that you can't with a script directly, but that's actually outside the scope of this presentation because I only have 5 minutes and I think I've wasted 4.5 of them talking. Also, this image right here. This is an image of Powersploit on GitHub. Powersploit is a PowerShell version of the Metasploit framework. Metasploit's been covered again and again and again here at SecKC. It's meant for exploitation of systems. Powersploit is specifically for Windows. It's pretty cool, so check it out if you're really interested in that. Alright, so if you're going to start talking about scripts, you have to talk about execution policy. But by default, a lot of Windows systems set execution policy to completely restricted. That means you cannot run scripts. And that's supposed to protect the user from being attacked by malware. Now, as security people, we should all think, oh, we're pretty happy with that, unless we're penetration testers, in which case we don't like that. But execution policy, it's a pretty easy concept. It's a lot like, again, I'm going to go back to Unix, read, write, execute, where only certain things can happen to a script depending on what permissions are set for them. But execution policy is a little more complicated. You can have certain options to restrict based on certificates, so kind of like how encryption uses some certificates. You can sign scripts, like Microsoft could sign a script so that every Windows machine can read it and know it's owned by Microsoft and execute it based on that. Or you could restrict based on what the source for the script was. For example, you could have what's called a remote signed execution policy. And that just means that any script that isn't from my box cannot be executed unless it's signed by a trusted publisher like Microsoft. Or you could have an all or nothing execution policy, which is any script can be run or no scripts can be run. Now, to make that last slide completely pointless, we'll go over how to bypass execution policy just in the regular Windows way. We're not going to get anything too hackery right now. I hope to go over that next month if my talk that will be submitted gets through.
Denied.
Denied. Crap. Okay. So, there's two primary ways of bypassing the execution policy. One of them is a persistent way, which is actually setting the execution policy with a tool called set execution policy. It's a very aptly named tool. And two of the common ones you'll see are unrestricted and remote signed, which just allows you to run scripts, test them, debug them. All things you kind of need to do if you're going to start getting into scripting with PowerShell. The problem is that it requires admin access. Hopefully you have that on your local machine. And if you don't, then that's probably not your local machine. You're probably at work, and people like me are going to see it and get on your ass about it. So please don't try and do that at work, unless you have the permissions for it. There's also a read file way, which is on a per script basis. And what you can do is you can read the script that you're wanting into memory, and then pipe it into a new PowerShell process, which means you take the memory that you just read in and then throw it into a new PowerShell process. PowerShell will execute that script just as if you execute it from the command line. The only difference is that you have to run it as a no profile, and that means that there's no execution policy defined, so Windows will run it automatically. But there's a big problem, and that's you cannot interact with this script. To be honest, I can't find a problem or a reason for that exactly, but I think it's just due to the way the piping works, and you can't really have a sort of a continuous interaction with a one-off process like that. If anybody has an answer for me, please see me after this talk. Please don't shout it out because I don't want to be embarrassed by how dumb I am. So the last part of this is interfacing with WMI. And here's actually where we start to talk about SecKC related things. So WMI is referred to as the Windows Management Interface. And all this is a set of tools that system administrators and other people, malware authors usually, can use to filter through event logs or go look at network interfaces, go look at running processes, stuff like that. So it's a good idea. The problem is that sysadmins and malware authors use often the same kinds of techniques. Getting running processes, useful technique for anti-forensics for malware authors. if you find that maybe VirtualBox is currently running on a system, you can know, oh, maybe I don't want to be running here too. Same thing with network adapters. If you find VirtualBox has a current network adapter, you don't want to be running on that system maybe. And that's an easy way to get around really novice reverse engineering that kind of automatically does things without actually thinking about them ahead of time. And lastly, I'd like to point out that as far as WMI goes, there are new methods that are constantly being developed. In fact, the inspiration for this talk was a Black Hat 2015 talk, that's right, this year, just a month ago, that's titled Abusing WMI to Build a Persistent, Asynchronous, and Fileless Backdoor by Matt Graber. It's a really cool talk. If you like white papers like I do, give it a read. He's got some great slides too that do a really good job of talking about the low level and the high level aspects of PowerShell and how this works. Again, that's outside the scope of this talk though. It's only a 5-minute talk, so I can't get too in depth with it. Other than that, that's it. I have some resources on here. If the slides get posted, there's some links that you can use too. That's it. Thanks.